To properly wire a 20 by 20 shed from an existing electrical panel, compliance with the National Electrical Code, or NEC, is paramount. Here's a detailed breakdown of the key considerations and a recommended wiring scheme. Firstly, a service calculation is essential. You must determine if the existing panel has sufficient capacity to handle the added load from the shed. This calculation will involve assessing the current electrical demands on the panel and comparing it to the panel's total capacity. Secondly, installing a subpanel next to the power pack is generally an acceptable practice. It allows for better distribution of power and isolation of circuits. However, the subpanel must be properly sized to accommodate the anticipated loads, and it must be equipped with appropriate circuit breakers or fuses to protect the circuits. You can feed both the existing air conditioning unit and the shed from this new subpanel. It's critical to ensure that the subpanel has sufficient circuit capacity for all the loads, including the air conditioner and any equipment or lighting in the shed. A second panel in the shed is not strictly required by the NEC, but it can provide additional flexibility and isolation for the shed circuits. This can be particularly useful if the shed will house multiple pieces of equipment or if you anticipate future electrical needs. Here's a recommended wiring scheme based on the NEC requirements and best practices. 1. Perform a comprehensive service calculation to confirm the existing panel's capacity to handle the additional load from the shed. 2. Install a subpanel next to the power pack and feed it from the existing panel. This subpanel will serve as the main distribution point for the shed and the air conditioning unit. 3. Install a dedicated circuit from the subpanel to the existing air conditioning unit. This ensures that the air conditioner has a reliable and protected power supply. 4. Install a subpanel in the shed and feed it from the subpanel next to the power pack. This provides a centralized location for the shed circuits. 5. Install circuits from the shed subpanel for all necessary loads in the shed, such as lighting, receptacles, and any equipment. 6. Ensure all circuits are properly protected with circuit breakers or fuses, and that the wiring is installed according to NEC standards. This includes using the correct wire gauge, conduit, and grounding methods. Other considerations include determining the most suitable method for running the electrical wires to the shed, whether through conduit or cable. Conduit provides better physical protection for the wires, while cable can be easier to install in some situations. Also consider the location of the shed and determine if the wires will be run underground or overhead. Underground wiring requires burying the conduit at the proper depth, while overhead wiring requires proper clearance from the ground and other structures. It is essential to install a disconnect switch near the shed for safety and convenience. This allows you to quickly and easily disconnect power to the shed in case of an emergency or for maintenance purposes. The service calculation is a critical step to determine if the existing electrical service can handle the additional load of the shed. The NEC provides guidelines on how to perform this calculation, which takes into account the existing loads in the service and the anticipated loads of the new shed. To perform a service calculation, firstly, gather information about the existing loads. This includes the amperage of all existing appliances, lighting, and other electrical equipment connected to the main panel. Secondly, determine the demand factor for each type of load. The demand factor is a percentage that accounts for the fact that not all loads will be operating at their maximum capacity simultaneously. Thirdly, calculate the total demand load by multiplying the amperage of each load by its demand factor and then summing the results. Fourthly, determine the anticipated loads of the shed. This includes the amperage of all lighting, receptacles, and any equipment that will be installed in the shed. Fifthly, add the anticipated loads of the shed to the existing demand load to determine the total calculated load. Sixthly, compare the total calculated load to the capacity of the existing service. If the total calculated load is less than the service capacity, then the existing service is sufficient to handle the additional load of the shed. If the total calculated load exceeds the service capacity, then the service will need to be upgraded. Installing a subpanel involves several important steps. Firstly, select the appropriate size of the subpanel. The size of the subpanel should be based on anticipated loads that it will be serving. It is generally recommended to choose a subpanel with more capacity than is immediately needed to allow for future expansion. Secondly, mount the subpanel securely to a wall or other suitable surface. The subpanel should be mounted in a location that is easily accessible and protected from the elements. Thirdly, run the feeder wires from the main panel to the subpanel. The feeder wires should be sized according to the amperage of the subpanel and the distance between the main panel and the subpanel. Fourthly, connect the feeder wires to the main lugs of the subpanel. Ensure that the connections are tight and secure. Fifthly, install circuit breakers in the subpanel to protect the individual circuits. The circuit breakers should be sized according to the amperage of the circuits that they are protecting. Sixthly, connect the branch circuit wires to the circuit breakers. Ensure that the connections are tight and secure. When running wires to the shed, several options are available including conduit and cable. Conduit provides the best protection for the wires and is required in some situations. There are several types of conduit available, including rigid metal conduit, electrical metallic tubing, or IMT, and PVC conduit. Cable is easier to install than conduit, but it does not provide as much protection for the wires. There are several types of cable available, including non-metallic sheath cable, or NM cable, and underground feeder, or UF cable. Underground wiring requires burying the conduit or cable at the proper depth. The NEC specifies the minimum burial depth for different types of wiring. Generally, conduit should be buried at least 18 inches deep, while cable should be buried at least 24 inches deep. It is also important to protect the wiring from physical damage by using a suitable conduit or cable. Overhead wiring requires proper clearance from the ground and other structures. The NEC specifies the minimum clearance for overhead wiring. Generally, overhead wiring should be at least 10 feet above the ground and 12 feet above residential driveways and parking areas, and 18 feet above public streets and alleys. A disconnect switch is an important safety device that allows you to quickly and easily disconnect power to the shed. The disconnect switch should be located near the shed in an easily accessible location. The disconnect switch should be sized according to the amperage of the circuits that it will be disconnecting. The NEC requires a disconnecting means to be installed at any structure, such as a shed or detached garage, that is fed from another building. This disconnecting means allows for the power to be shut off to the entire structure in case of an emergency. The disconnecting means can be a circuit breaker or a switch. The disconnecting means must be readily accessible and located either inside or outside the structure. The disconnecting means must be marked to indicate that it is the disconnecting means for the structure. Grounding is an essential part of any electrical installation. Grounding provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The NEC specifies the requirements for grounding electrical systems. All electrical equipment must be properly grounded. Grounding is achieved by connecting the metal parts of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode must be connected to the earth. The grounding conductor must be sized according to the amperage of the circuit. Bonding is another important part of any electrical installation. Bonding is the process of connecting together all of the metal parts of an electrical system to create a common ground. Bonding helps to reduce the risk of electrical shock. The NEC specifies the requirements for bonding electrical systems. All metal parts of an electrical system must be bonded together. Bonding is achieved by connecting the metal parts of the system to a bonding conductor. The bonding conductor must be sized according to the amperage of the circuit. Overcurrent protection is an essential part of any electrical installation. Overcurrent protection protects electrical circuits from damage caused by excessive current flow. Overcurrent protection is provided by circuit breakers and fuses. The NEC specifies the requirements for overcurrent protection. All electrical circuits must be protected by overcurrent protection devices. Circuit breakers and fuses must be sized according to the amperage of the circuit. Arc fault circuit interrupters, or size, are a type of circuit breaker that provides additional protection against electrical fires. A size detects arc faults, which are a common cause of electrical fires. When an arc fault is detected, The FSI will trip, cutting off the power to the circuit. The NEC requires FSIs to be installed in certain locations, such as bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, are a type of receptacle that provides protection against electrical shock. GFCIs detect ground faults, which occur when electricity flows through an unintended path to ground. When a ground fault is detected, the GFCI will trip, cutting off the power to the receptacle. The NEC requires GFCIs to be installed in certain locations such as bathrooms, kitchens, and outdoor areas. Wiring methods refer to the different ways in which electrical wires can be installed. The NEC specifies the requirements for different wiring methods. Some common wiring methods include conduit, cable, and wireway. Conduit is a metal or plastic tube that is used to protect electrical wires. Cable is a bundle of electrical wires that is encased in a protective sheath. Wireway is a metal trough that is used to support and protect electrical wires. Boxes and fittings are used to enclose and protect electrical connections. The NEC specifies the requirements for boxes and fittings. Boxes and fittings must be made of approved materials and must be sized appropriately for the number of wires that they contain. Conductors are the wires that carry electricity. The NEC specifies the requirements for conductors. Conductors must be made of approved materials and must be sized appropriately for the amount of current that they will carry. The insulation on conductors must be rated for the voltage and temperature of the application. The NEC provides tables that specify the allowable ampacity of different sizes of conductors. These tables take into account the type of conductor, the insulation rating, and the ambient temperature. Electrical panels are used to distribute electricity to different circuits. The NEC specifies the requirements for electrical panels. Electrical panels must be made of approved materials and must be sized appropriately for the number of circuits that they will serve. Electrical panels must be properly grounded and bonded. Lighting is an essential part of any electrical installation. The NEC specifies the requirements for lighting. Lighting fixtures must be made of approved materials and must be installed in accordance with the manufacturer's instructions. Lighting circuits must be protected by overcurrent protection devices. Receptacles are used to provide a point of connection for electrical appliances and equipment. The NEC specifies the requirements for receptacles. Receptacles must be made of approved materials and must be installed in accordance with the manufacturer's instructions. Receptacles must be properly grounded. Appliances and equipment are used to perform various tasks. The NEC specifies the requirements for appliances and equipment. Appliances and equipment must be made of approved materials and must be installed in accordance with the manufacturer's instructions. Appliances and equipment must be properly grounded. The NEC provides specific requirements for different types of appliances and equipment such as refrigerators, washing machines, and air conditioners. Electrical safety is of utmost importance. Always follow the NEC and local electrical codes when installing electrical wiring. If you are not comfortable working with electricity, hire a qualified electrician. Always turn off the power before working on any electrical circuit. Use caution when working with electricity. Electricity can be dangerous if not handled properly. Always test electrical circuits before working on them to make sure that they are de-energized. Use insulated tools when working with electricity. Wear safety glasses when working with electricity. Consult with a licensed electrician to ensure the safety and compliance of your electrical installation. Ignoring these guidelines could lead to dangerous situations.